Hello,
Hello, good evening.
good evening Diksha Didi. So today we are going to continue with functions using pointers. So yesterday we saw function definition and passing by value and all about functions, basics about functions, and today we are going to continue with functions using pointers. Great.
Okay.
So I'm just sharing my screen. So over here function using pointers. So function fun, that let's just revise a bit over here from pass by value. So we had a fun function which didn't return anything and we were just checking the behavior of pass by value. So we had an x variable over here 20. We passed that variable to fun and that was setting the x variable it got as 30. But as this is passing by value and this is a separate variable for the function, so x equals to 30 will be different from the 20x over here. So x value over here outside in the main method will remain 20 only, and when we print x value we'll get 20. Now we are going to see how to pass pointers to functions. So a function fun expects a pointer ptr to an integer or an address of an integer. So over here it was we were trying to do, we were trying to change the x value that was over here from this function, right? But as we were not giving any pointer over here and the memory location of this x was different from this x, that's why the value over here was not changing. So over here what was happening, it was expecting a pointer, right? So it modifies the value at the address pointer. The dereference operator star is used to access the value at an address. In the statement star ptr equals to 30, the value at the address ptr is changed to 30. So over here this is the explanation of the code below that we are going to see. The address operator AND is used to get the address of a variable of any data type. In the function call statement fun and x, the address of x is passed so that x can be modified using its address. Now let's see what is happening in this code, right? And then we'll just go through the explanation once again so it will be more clear. So we have this fun function over here. We are getting a pointer of integer data type. So we are going to get a memory location where an integer will be stored, and what we are saying, we are dereferencing the pointer and setting the value whatever was there in the memory location, we are changing that to 30. Now we have x equals to 20 and we are passing x's memory location. So what is happening, it's getting x's memory location, it is dereferencing x memory location, and it is changing whatever is there in x memory location to 30. And now outside, after this function call, outside of this function also, in this function over here, the outside x will be changed to 30, and when we print x we'll get 30. So that's what they are telling. The fun function expects a pointer to an integer, so like it's expecting a pointer to an integer. It modifies the value at the address pointer, so it modifies the value at the address pointer. The dereference operator star that was used over here as a dereference operator, it is also used to save pointers over here. Like over here we are using it for saving pointers, and over here we are using it to dereference, right? So the dereference operator star is used to access the value at an address, right? So it is used to access the value at an address. So in the statement star ptr equals to 30, the value at the address pointer is changed to 30. So whatever pointer we are getting over there, the value is changed to 30. The address operator and is used to get the address of a variable of any data type. In the function call statement fun and x, the address of x is passed so that x can be modified using its address. Great. So this was the functions using pointers example, right? Now we are going to see difference between call by value and call by reference in C++. So over here we have call by value that was over here, right? And this is call by reference, right? So in call by value, a copy of value is passed to the function. So a copy is passed, right? So when we were trying to change the x outside from inside the function, we were not able to do that as a copy was passed and not the element itself. So where x itself was not passed, its value was passed, that was saved in another x variable, right? That was different from this x, right? So a copy is passed to the function. In calling by reference, an address of value is passed to the function. So over here we are passing the memory location, that is the address, right? That's a the address that we get is being passed to the function in calling by reference. Then in call by value, changes made inside the function is not reflected on other functions, and changes made inside the function is reflected outside the function also in calling by reference. Actual and formal arguments will be created in different memory location. So what they are saying, the actual arguments, so we saw over here that the actual arguments are the arguments that are being passed when we are calling the function, and the formal arguments are where we are receiving the values, right? So they are just saying that the actual arguments memory location, that is over here, and the formal arguments memory location will be different. And in calling by reference, actual and formal arguments will be created in the same memory location. So over here this what we are passing, so we are passing the x's memory address, and that is further being changed, right? So what is happening, the changes are being reflected outside also. So the actual and formal arguments will be created in the same memory location, right? So pointer, what is it? It's just referencing to this x variable, right? So basically they are referring to the same memory location, or they are created to the same memory location. It's one of the created in the same memory location, it's one of the same things, right? So now we are on points to remember about functions in C++. So most C++ programs has a function called main, right? So we have this function called main, that is a self-calling function, right? That is called by the operating system when a user runs the program. So usually when you create functions like fun and all, we have to call them ourselves, but the main function is directly called when the program is executed. So every function has a return type, right? So every function has to have a return type, and if you don't want to return anything, you can just give void over here. So if a function doesn't return any value, then void is used as a return type. Moreover, if the return type of the function is void, we still can use the return statement in the body of the function definition by not specifying any constant, variable, etc. with it, by only mentioning the return statement, which would symbolize the termination of the function as shown below, right? So before going down, what we could have done till now, we are just not doing anything. In void, we think that we don't have to give the return statement, but if we want, we can give the return statement, just we don't have to give any value after it, right? So when giving void, to like to tell that this is the end of the function, right, you can give this return statement, right? So over here, like, you write your function body, and then function execution would get terminated when you give the return keyword without any value with it. So to declare a function that can only be called without any parameter, we should use void fun void, right? So what we should do over here, if we have no parameters, we should do void fun void instead of just leaving it empty. Leaving it empty will also work, but it's always suggested or advised that you should give void over here inside the parameters place also. So as a side note, in C++, an empty list means a function can only be called without any parameter. In C++, both void function and void fun void are the same. So if you don't give void in between the brackets, or you give void in between the brackets, if you have no parameters, that will be the same thing. So now we are going to look in detail about the main function. Before that, I just want to confirm if everything is clear till now.
Yes, clear.
Alright, great. So the main function is special function. So every C++ program must contain a function named main. So every C++ program, it's compulsory to have this function called main. It serves as the entry point for the program. So the computer will start running the code from the beginning of the main function, right? So whatever you give in the main function will get executed when you run the program. So there are types of main functions also. So one is without parameters, right, that we are usually using right now. So in all of our programs, the main function does not have any parameters. And one is with parameters, so we can give parameters to the main function also, right? So we are going to see how we can use them. So the reason for having the parameter option for the main function is to allow input from the command line. So if we mostly right now we are running this C++ code with the Geeks for Geeks editor or Replit, right? But when we give parameters to the main function, it's mostly given to basically allow input from the command line. So when you use the main function with parameters, it saves every group of characters, right? So separated by a space after the program name as elements in an array named argv. So what they're telling that when you are running the program, so in the command line there's a certain command to run your C++ code, right? So let's say we have this is the command to run the C++ code. Now whatever you give after this command, right, so x, y, z, etc., right, so all of these are separated by spaces and they are all saved in a list called argv, right? So these they are all saved in an array named argv. So since the main function has the return type int, the programmer must always have a return statement in the code. The number that is returned is used to inform the calling program what the result of the program execution was. So basically we can omit the return statement over here, but we should not, as it first of all signifies the end or tells us the end of the program, and second of all it tells the system that basically we have reached to the end of the program, and the system gets the value, right? So basically the number that is returned is used to inform the calling program. So program that is being called, it is used to inform that what the result of the program execution was. So we are just giving the result of the program execution. Returning 0 signals that there were no problems. So when you run the program and you return 0 in the end, this means that you have reached to the end of your program and the program knows that there was no problems in the execution of the program. Now we are on C++ recursion that we have already seen in very much detail in our basic course, right? And we are just going to brush over it also right now. So when function is called within the same function, so when a function is called in with the same function, so if you have an x function and you call it inside x only, so you call x inside x, that is known as recursion in C++. So a function which calls the same function is known as recursive function. So over here this recursion function that we have created is a recursive function. Why? Because we are calling the same function inside this function, right? So it is known as recursive function. A function that calls itself and doesn't perform any task after a function call is known as tail recursion. So when you have a function that calls itself and it does not perform any task after the function call, it is called tail recursion. So when you are not doing anything after this function call, this is known as tail recursion. In tail recursion, we generally call the same function with the return statement. So what is tail recursion? When you do nothing after calling the same function, that is tail recursion, and we generally call the same function with return statement. Alright, so we are going to see that we have already seen all of this in very much detail, right? And this was just a quick brush over recursion. They have not gone into detail in it, right? But we are going to go further in detail in it in the course further, right? So C++ passing array to function. So a recursion we have already seen, so we are not going to go deep into it right now, right? But we might go deep into it later. So right now let's move on to the new concept or new topics. First we'll do C++ passing array to a function. So basically what we are going to see how to pass an array to your function. So in C++, to reuse the array logic, we can create function, right? So if you want to reuse the array logic, we can create function. So to pass array to function in C++, we need to provide only the array name. So what we have the function over here, and when we are calling it, we just have to give the array name between the brackets, and the array will be passed. Here is an example of the same. So over here what we have a print min function, right? And what is happening, we are just declaring the print min function right now and not giving it the function body, right? We are just declaring it print min, right? And we are just accepting an array of 5 elements in this print min function, right? Now the thing is, we also saw this part, that when we declare something on the top, right, and we use it in the main function and we define it later, that will work. But if you do the declaration not on the top, and you directly do the declaration and definition all after using it, so over here, if we wouldn't have given this statement and we are using it over here, right, and we are declaring and defining it afterwards, that will lead to an error, as it won't be able to find the function. But when you are declaring it over here without giving it the body and then trying to use it, right, then this will work, as the program knows that there is this print min function that exists, right? So it will search for the print min function, it will get it over here, and this will be called. So what we have in the main method, we have an array of 5 elements, in which we have 30, 10, 20, 40, 50, and we are calling print min array that will print the minimum value in this array. So in this function, what we are doing, we are creating an integer min and we are setting it by default to array 0. Array 0 is 30, so we are saying min is equal to 30 right now. Then what we are doing, we are saying for int I equals to 0, I less than 5, I plus plus. So we are creating a loop to loop on this array, right? Then what we are doing, we are saying min is greater than array I. So whatever the current minimum we have saved, if it is greater than the element we are on when we are looping, so first it will say 30, right? So array I, and it will check min greater than array I. So array I in the first iteration is 30, so and min is also 30. So 30 greater than 30, that is false, so it won't change the value of min. Then what it will go, it will go to the second iteration, it will check min greater than array I. Next, in array I's value will be 10. So 30 is greater than 10. So what will happen, we are setting min's value to array I. So we are changing the minimum value to 10, right? And next, what we are doing in the next iteration, we are checking if min is greater than array I. So now min is 10 and array I is next 20, right? So 10 is greater than 20, that is false, so it will go to the next iteration, and then it will check 10 is greater than 40, that will also be false, so then it will check 10 is greater than 50, and that will also be false, so it will reach to the end of the array, and this it will come out of this for loop. In the end, in min, we have saved the value 10, and when we print minimum element is min, that will print minimum element is 10, right? So is this example clear?
That's clear.
Great. So next we are on C++ overloading. So if we create two or more members having the same name but different in number or type of parameter, it is known as C++ overloading. So what is happening, if we have a function, right, with the same name, right? This is used, so if you have a function with the same name, so example x, right? So if you create x 2 times, right, that will be allowed if you have what will that is allowed, right? And what you can do, you can either like change the data type of its arguments, or you can increase or decrease the number of arguments in that x function. So what will happen, the function will be overloaded. For example, if you have an x function which is accepting 2 arguments, and you also have an x function which is accepting 1 argument, so when you call x, if you pass 1 argument to x, then the 1 argument function will be called. If you ask 2 arguments to x, then the 2 arguments function will be called, right? So we are going to see all of this in action also, right? Basically, overloading is changing the type of parameters or changing the number of parameters to basically create functions with the same name. So creating functions with different behavior but with the same name, right? So we can overload methods, we can overload constructors and indexed properties, right? So all of these we are going to see. We know methods are basically mostly we refer to whatever functions we have in class, we refer to them as methods, right? So maybe over here also they are referring to that only as methods. Then constructors, what we have constructors, like you have a class constructor, right? So you create a constructor in a class, right? So that can also be overloaded. And index properties we are going to see about further in the course. So it is because these members have parameters only. So why these all can be overloaded? Because methods have parameters, constructors have parameters, and index properties have parameters. That's why these can be overloaded only, right? So there are two types of overloading in C++: function overloading, operator overloading. So let's see for function overloading first, and then we're going to see operator overloading. So function overloading is defined as the process of having two or more functions with the same name but different in parameters is known as function overloading in C++. So when you have two or more functions with the same name but different in parameters, it's known as function overloading in C++. So in function overloading, the function is redefined by using either different types of arguments or a different number of arguments. So it is only through these differences compiler can differentiate between the functions, right? So if you have different types of arguments or different number of arguments, then the compiler will be able to differentiate between the functions. The advantage of function overloading is that it increases the readability of the program because you don't need to use different names for the same action. Alright, so we are going to see that in action now. So basically we have a class cal, right, and we are right now doing function overloading. What we have over here, we have public methods add, right? So in one method add, we are taking in two arguments and returning the sum of those two arguments. In the other one, we are changing the number of arguments and we are taking in three arguments and returning the sum of all of those three arguments. So now when we have to add two values, then also we can use this add function. When we have to add three values, then also we can use this add function. When we pass it two values, then this add function will be called. When we pass it three values, then this add function will be called, right? And one more thing to note, these are static functions, so these will not be called on the object of the class. These will be called directly on the class itself. So if we create an object of the class, right, so we are creating an object of the class, right, and then using them, we could have also used them directly on the class. So if we would have said cal.add, that would have also worked perfectly. So we are getting error over here, so I'll just see once expected primary expression. All right, I'll just look into this and get back to you in the next class that what this error is, right? So right now we should not waste time on this error. I'll just get back to you in the next class on this thing, right? So here's an example when the type of arguments vary. First we had the number of arguments changing, so over here two arguments, over here three arguments, right? And over here what we are going to check the example where types of the arguments is changing. So we have a definition of mul function in which we are taking two integers, and over here in mul we are taking float and int, right? And in the mul function in which we are taking two integers, we are just multiplying them both. In the mul function in which we were taking float and int, we are actually changing it to double, right? So if we have defined over here that we'll take float, we can in the definition we can change that, right? So we can say we want to take double, right? So that will also work perfectly fine. So over here what we have, when a double expression, right, so when you pass a float and an integer, then this malfunction will be called. When you pass two integers, then this malfunction will be called. Both are multiplying both the two arguments. So when we have an integer r1 which is calling a malfunction and passing it 6 and 7, then we have a float variable r2 in which we are passing 0. 0.2 and 3 to the malfunction. So first, this malfunction is being called from here, right? And second, this malfunction is being called from here, right? And then we are basically going to get the result 6 into 7 42 and 0.2 into 3 0.6. All right, now all I'll just get back to this in the next class, but I just hope that everything, the rest is cleared.
Yeah, the rest is clear.
All right, great. So function overloading and ambiguity. So when the compiler is unable to decide which function is to be invoked among the overloaded function, this situation is known as function overloading. So basically, what they're saying, when the compiler is unable to decide when function is to which function is to be invoked among the overloaded function, this situation is known as function overloading. So one is overloading, in which you are giving multiple definitions to the same function name, right? And one is overloading, you can put it like that, right, in which where the compiler won't be able to decide that which function to call. So you can also put it as overloading, right? So you can also put it in that way, overloading, right? So when the compiler shows the ambiguity error, the compiler does not run the program. So we are going to see the causes of function overloading, or like function overloading, you can say, right? And we are going to see examples of this also. One cause is type conversion. Next is function with default arguments, and then next is function with pass by reference. So where what is happening, when will the compiler be ambiguous? Here's one example. So we have a fun function in which we are going to accept an integer, then we have a fun function which is accepting a float. Then we are giving the definition to the fun function, right, that is taking integer and printing the value of I is I, right? And then we have this fun function float over here. What it's doing is just saying value of j is j, right? And what we are doing, we are calling fun 12, right? So it should call this one, and when we are calling fun 1.2, it should be calling this one. Let's run this program. We get an error, right? So we are getting the call of overloaded function double is ambiguous, right? So we are getting the ambiguity error. Let's see why. So the above example shows an error call of overloaded fun double is ambiguous, right? So we are getting this error. So the fun 10 will call the first function, right? So the fun 10 will call the first function. The fun 1.2 calls the second function according to our prediction. But this does not refer to any function as in C++. All the floating point constants are treated as double, not as float. So if we replace float to double, the program works. Therefore, this is a type conversion from float to double. So what is happening? We are saying 1.2, we are passing 1.2. So now we are trying to treat this as float, but by default any decimal number like in which we have a point is treated as double in C++. So it is ambiguous whether to use the float, the fun float one or not, right? So that's why we are getting an error. If this would have been, all right, if we would have said double over here and double over here, that would have worked perfectly fine, right? So that is working perfectly fine. Next case of this ambiguity error is function with default arguments. So we have a function that is taking an integer, and then we have a function which is taking two integers, right? So this is changing of the number of parameters. Now now when you have this function over here, we are taking in I, right, and we are saying value of I is I. When we have this second function, we have a and b, but b we are giving a default value. So now in this we are saying value of a is a, value of b is b, right? And when we call function 12, why are we getting an ambiguity error? So look over here, if it calls this function, that then also it is correct, right? Why? Because what will be happening, this is only accepting one argument, we are only giving one argument, that's why this function to be should be called. But then the compiler will be confused, why not this function? Because what is happening, we are giving one argument, right, that is compulsory. The first argument was compulsory over here. The second argument over here is a default argument. What is default argument? Default argument is that whenever you don't give that argument, then also it will give it a value. So over here it is getting confused. So what we intended to do, it is getting confused. If we only intended to give one argument and we wanted to only call this function, or we actually wanted to use a default value of this and wanted to give the value of the first argument over here, so it is getting confused whether to call this function or this function. That's why we'll get the same error, call of overloaded func int is ambiguous, right? So we are getting this ambiguity error over here also. So the above example shows an error, call of overloaded func int is ambiguous. So func int a int b equals to 9 can be called in two ways. First is by calling the function with one argument, right? So fun 12, and another way is to calling the function with two arguments, fun 4 comma 5. So fun int I function is invoked with one argument, therefore the compiler could not be able to select among func int I and so it was not able to select between this and this basically, right? But if we give two arguments over here, three, like for example we give 3 also, then this will work, and I'm just going to explain that in a second. So now this is working. Why? Because we are not giving one argument to the function, so this won't be called, right? But we are giving two arguments. This was a default argument, and we are giving two arguments. So a is getting 12, b is getting 3, right? So this function that was accepting two arguments will be called, right? So we are giving it two arguments. Next, finally, we have function with pass by reference. So over here also we can get an ambiguity error. One is a function where over here we have a function that is taking in an integer, and over here we have a function that is taking in a address of an integer value, right? So in the main function what we are doing, we are saying a equals to 10 fun a, so we are passing it the a value. So the definitions we are giving over here, let's just see the definitions, right? So we are getting first, in the first definition where we are accepting the integer value of x is x, and in the second one where we are taking a pointer over here, we are saying value of b is b, right? So when we are calling function a, it exactly does not know which fun should it call. Why? Let's see over here. So the above example shows an error, call of we are getting this error. Let's just see first, right? So we are getting the error. So this example is showing this error. The first function takes one integer argument and the second function takes a reference parameter as an argument, right? So what is happening, this is not taking in a pointer, my bad, this is not taking in a pointer. It would have been taken from a star, right? So it would have been taking a pointer from star pointer, right? That would have been taking the address of the variable. Over here we are saying and, right? So we are taking a reference variable. What do we mean by reference variables over here? A variable that is pointing to another, basically when a variable is pointing to some memory location, right? So if, for example over here, let me just I'm not able to explain it, so I'll just show you an example. So For example, integer and b is equals to a, right? So this is a reference variable where b is pointing to a, right? So now what is happening, a is, sorry about that, right? So a is pointing to 10, right? So a is pointing to a memory location in 10, where 10 is saved, right? So it is not able to decide, is a reference variable or is it a normal variable, as a is pointing to a memory location where 10 is stored, and it does not know that if it does not know if a was created like normally over here, or if we had some or other variable like 10 and we created a like this. So it does not know if we created a like like a reference variable over here like this, or we created it normally, right? So it does not know that, right? So that's why it is getting confused that whether to pass a in a reference variable function or in the normal function. So in the case the compiler does not know which function is needed by the user, as there is no syntactical difference between function int and function int and, right? So there's no syntactical difference. Next we have friend function, right? So we are going to see about friend functions. A friend function is a special function in C++ which, in spite of not being member function of a class, has privilege to access private and protected data of a class. So now there are special types of functions, friend functions, that we can give over here, like friend, using the friend keyword or something, right? So this is a very special type of function, right, where it is not a member of so it's not a member function of a class, but it has privilege to access private and protected data of a class. So a friend function is a non-member function or ordinary function of a class which is declared as a friend using the friend keyword inside the class. So it's a non-member function. Oh, so it's basically a non-member function, and it works like an ordinary function of a class which is declared as a friend using the keyword friend. So it is declared using the keyword friend inside the class. By declaring a function as a keyword, all the so by declaring a function as a keyword, all the access permissions are given to the function. So basically when you create the function using the friend keyword, this it gets the access to access private and protected members of the class. So the keyword friend is placed only in the function declaration of the friend function and not in the function definition. So when you are declaring the friend function, then only the friend keyword is placed. When you're giving the definition to the function, there's no need to of giving this friend keyword. When the friend function is called, neither name of the object nor dot operator is used. So when you will call this friend function, there's a different way of calling it. Neither the name of the object nor the dot operator is used. So if there's an example over here, we can see, look at that, right? So yeah, so we have this find max friend function that we are going to look at in detail, right? But we are calling it neither with the object of the like class. So largest class object is L, so we are not saying L dot find max, not we are using the dot syntax, right? So we just have to directly call it, right? So right, however it may accept the object as argument whose value it wants to access, right? So what you can have, your find max function or the friend function can get receive objects of classes, right, that any function can also receive, right? And finally friend function can be declared in any section of the class, i.e. public or private or protected. So it can be declared in as public, private or protected, that will be the same thing. Now the class is less than 1 minute left, so there's less than 1 minute left in the class. So I'm going to get back to you on that example in which we were getting an error, and we are just going to continue in the next class. So thank you.
Okay, thank you.